Hey, what's up guys, this is TechHertz Vlog, and in today's video I'm going to show you how to connect two reed switch sensors in series to activate a mini relay to send positive signal to a PNP type input configuration PLC system. Let's take a look at the circuit diagram. Here in the diagram, we have two pneumatic cylinders, and we have also two reed switch, which is placed in the initial position or the retracted position of the cylinders. So this is the retracted position. So piston rod is retracted, fully retracted. So these are the reed switch sensors, sensor 1, sensor 2, and initially this reed switch sensor is activated because see the orange LED light is switched on because the piston rod with the magnet is initially here. So reed switch is, if detected by magnet, it will give signal to the reed switch. That's why it is switched on. So reed switch sensors is a 3-wire, so there is a brown, a blue, and a black wire. So the brown is positive, blue is negative, and black is the output. So when it is connected in series, the sensor number 1, which is this one, its output, which is black color, this wire must be connected to the brown wire of the second sensor. Because we need to connect these two sensors in series. And of course the blue wire connected to negative, and the black wire, the output wire, is connected to the coil of the mini relay, and the other terminal of the relay is connected to negative. And in order to send positive signal to the PLC, we can use the contact of the relay, NO contact, normally open contact, and then send signal, positive signal to the PLC or PNP type input configuration. So in the next view, I will show you the actual connection of these two reed switch sensors. Regarding the power supply, the output is 24 volts DC. This is the positive, and it is connected to the positive terminal block, and negative is connected to the negative terminal block, just for your info. This is the actual terminal connection of the two reed switch sensors. So sensor number 1 is this one. Sensor number 2 is this is its cable. So sensor number 1, as per the diagram, brown is connected to positive, By the way, our power supply is a 24 volts DC output. Okay. Sensor number 1. This one. So the brown, which is this one, is connected to the positive, and the blue is connected to negative. 0 volts is negative. The blue of this sensor 1 is connected to the negative. Okay. These terminals are negatives. Okay, there is a loop, and this terminal from here are positive. Next, this is the important, no? The black or output wire, the black wire or the output wire of the sensor 1 is connected to the brown wire of the sensor 2. Let us check it in the actual sensor. So this is the sensor number 1, no? This is the sensor number 2. This wire. Now we have to check it. So sensor number 1, sensor number 2. Sensor number 1, black wire, which is this one. This one. Yeah, this one is connected to the brown wire. Yeah, this is the brown wire. Yeah, this is the brown wire. So black wire of sensor number 1 is connected to the brown wire of sensor number 2. This is sensor number 2. Okay, I hope that you get the connection. Sorry for this terminal connection. Sorry for this inconvenience, no? Anyway, based on the diagram, the blue wire of the sensor number 2 is connected to the negative, and the black wire, which is this one. Yeah, this one. The black wire of sensor number 2 is connected to the relay terminal. So black wire of sensor number 2, which is this one, connected to the terminal of the relay, positive terminal of the relay, and the negative terminal of the relay coil, which is this one, is connected to the negative. So this one connected to the negative. Yeah, this one. And of course this contact, even though it is not wired, so the contact of this relay is to be used to send positive signal to the PLC. Now the operation of the circuit. Based on this diagram, once this sensor 1 detects a magnet, this sensor will be triggered and will close the contact. thus giving a positive output on the black terminal wire. And if the sensor 2 also detects magnet, the contacts also will close, thereby giving this positive signal coming from the sensor 1. It will go at the output of black color and give positive signal to the relay, thus energizing the mini relay. Okay, we can see from the actual sensor 1 and sensor 2 are activated. It means mini relay will be activated. So based on the diagram, if sensor 1 did not detect a magnet, like for this one, I will extend this, partially extend this cylinder number 1. You can see that the 2 reed switch sensor will switch off. Okay, I partially extend this cylinder number 1. This each piston rod partially extend, just to move each magnet away from the sensor. And as per the diagram, once this one did not detect a magnet, this will not be activate. So it means that the contact from the positive signal will be switched off, cutting this positive signal to the sensor number 2. That's why sensor 2 is also switched off. You can see the difference now. And of course, relay will be switched off also. Okay, next, I will return this, retract this cylinder number 1. Check this reed switch sensor. Okay, now this is retracted. Cylinder number 1, sensor 1 and sensor 2 are activated, because since they are connected in series, this is closed. Positive signal will also give signal to the sensor number 2. That's why both are lighted up or activated. And of course, mini relay is also activated. What about if cylinder number 2 will be extended? Let us see what will happen. So I will extend this. Check sensors. What will happen? Okay, this is partial extended. Means magnet from here goes away from the reed switch sensor, and only sensor number 2 is off. Why is it that sensor number 1 is still on? Let us see in the circuit diagram. Since sensor 1 and its magnet is still here, and it is first connected to the plus 24 volts DC, and its blue terminal is connected to the negative. That's why still it has a orange output signal, but its output signal, which is coming from the black color, sending to the brown of the sensor number 2. But the problem is not the problem, but the situation is this sensor number 2, its magnet is already extended or moved from here to here, and if it will not detect a magnet, this will be open, thereby the output orange LED signal will be switched off, and at the same time mini relay is also off. So that is the reason why only sensor number 2 is switched off and sensor number 1 is still switched on. But if cylinder number 1 is extended, both sensors will be switched off. Okay, based on this circuit diagram, since they are connected in series. So I will retract cylinder number 2, check this number 2 sensor. Okay, now sensor number 2 is activated and mini relay is activated. Two are activated. Okay, cylinder number 1 extended, both will be switched off, both sensors will be switched off, and of course mini relay is also switched off. I will retract cylinder number 1, both sensors will be activated, and of course mini relay is activated. But when cylinder number 2 is extended, only sensor number 2 will be deactivated, sensor number 1 is still activated, but the mini relay is deactivated. But anyway, the purpose of this circuit is just to show that instead of sending 2 input signal to the PLC, we can use only 1 input signal to the PLC, and the goal is to have a interlocking for the production operation or sequence of operation, that the 2 pneumatic cylinders will be at its initial position or retracted position before the next sequence of operation. So by this configuration, we save 1 input signal. That's all for this video. I hope that you have learned how to connect 2 reed switch sensors in series connection and activating a mini relay. Actually, if the PLC configuration is PNP type, you can remove this mini relay and direct this sensor number 2 black wire output directly connected to the input terminal of a PNP type input configuration PLC module. Okay, that's all for this video. Hope to see you in my next video. Bye and peace.